On September 20th, 1942, at Naval Air Station North Island in San Diego, California, Lieutenant Commander Eddie Sanders clutched the yoke of an aircraft that had no business being under American control. Sweat slicked his palms, even with the brisk morning breeze drifting in from the Pacific. The dashboard in front of him showed readings in Japanese script. The mechanisms seemed alien to his touch. The whole cabin reeked of lubricant and exotic composites. Outside the canopy, security personnel with weapons encircled the hangar, their directives unambiguous ever since this invaluable asset had shown up 3 weeks prior. This stood as the planet's priciest warplane, and Sanders was on the verge of becoming the initial U.S. pilot to take it aloft. He eased off the brakes, and the Mitsubishi A6M2 Model 2110 Interceptor taxied ahead, its power plant humming with unexpected refinement. In just moments, this initial evaluation run would reveal flaws that would reshape U.S. dogfighting strategies and seal the fate of Japan's sky dominance. The intelligence concealed within this seized vessel would aid in developing a countermeasure that would fell more than 5,000 hostile planes and shift the momentum of the Pacific conflict. The shift didn't start with this sortie, however, but 5 months before, amid a drenched Atoll in the Aleutians, where a novice Japanese aviator executed his last touchdown on June 4, 1942. That very day, roughly 300 meters eastward, U.S. dive bombers were obliterating 4 Japanese carriers during the Battle of Midway, altering the Pacific theater irrevocably. Yet, in the Aleutian chain off Alaska, a more modest incident was playing out, one that would carry equal weight in the long run. The 19-year-old petty officer first class, Tadayoshi Koga, lifted off in his Zero from the carrier Ryujo as part of a feint assault on the U.S. outpost at Dutch Harbor. The early sortie unfolded as intended. At first, Koga, alongside his escorts, Chief Petty Officer Makoto Endo and Petty Officer Tugo Schickard, hammered Dutch Harbor with fierce precision, downing a U.S. PBY Catalina reconnaissance plane and raking the crew in the surf below. The Zero handled flawlessly, outpacing and outturning every opponent the Americans had in service. Then, one stray round altered the course of events. Anti-aircraft fire from Dutch Harbor, probably from a .50 caliber gun, pierced Koga's machine, rupturing the oil return conduit. For an engine reliant on exact fluid flow, this spelled catastrophe. Fluid gushed from the breached pipe, and Koga understood he might have only 15 minutes until the motor locked up entirely. He signaled his squadron leader about the injury and veered toward Akutan Island, 25 miles east of Dutch Harbor, marked by Japanese strategists as a backup strip. A sub lurked nearby to retrieve any pilots who went down. Nearing Akutan Island, Koga eyed what looked like an ideal spot for an unplanned touchdown. A broad expanse of level meadow about half a mile from the shoreline at Broad Bight. His escort hovered overhead while Koga lined up, undercarriage lowered for a standard gear-down settling. Schickard, passing above, caught a glint of moisture amid the blades on his next loop. Dread hit him as he grasped that the patch was a swamp, the turf hiding ankle-deep sludge and pools. He attempted to transmit an alert, but the moment had passed. Koga was locked into his descent. The Zero's tires met the turf at around 80 nanometers. For an instant, the arrival appeared to go smoothly. Then the primary struts plunged into the yielding ooze under the overgrowth, snagging with brutal power. Momentum dominated. The nimble interceptor, its rear still moving at touchdown velocity, somersaulted fully in a savage tumble. The plane crashed inverted into the mire with a shattering jolt. The impact broke Koga's neck on the spot, ending his life before he could inhale again. His remains hung from the harness in the flipped cabin, his sidearm and katana blade secured at his side, his uniform unmarked save for the careful bandages encircling his chest from prior wounds. Overhead, Koga's companions confronted a torturous choice. Protocol demanded they eliminate any crippled Zero to keep it from enemy capture. They orbited the wreck repeatedly, weapons primed, scanning for hints that their fellow might have endured. The craft looked so undamaged, perched belly up in the wetland like a flipped shell, that they couldn't force themselves to shoot. Maybe Koga lived, pinned, hoping for extraction. They refused to end their ally based on the slim hope of his endurance. Following a few extra sweeps with tanks nearing empty, they grudgingly headed westward back to the Ryujo. The sub tasked with saving fallen airmen probed the seas near Akutan for hours until the U.S. destroyer USS Williamson forced it off. Koga's corpse and his Zero lay isolated in the Aleutian wilds, 5,000 miles from Japan, poised to disclose every mystery. One of the Imperial Japanese Navy's most dreaded assets remained untouched for 5 weeks in the Akutan marshlands. The wreckage was concealed from typical maritime paths and routine flyovers, tucked away in a narrow valley shrouded by the endless Aleutian mist, which allowed only about 6 days of clear sight each month. The carrier groups that could have hunted for Koga had pulled back to the west following the disastrous loss at Midway. The novice aviators' end merged into the mounting toll of a conflict increasingly unfavorable to Japan. That changed on July 10, 1942, when a U.S. PBY Catalina reconnaissance plane under Lieutenant William Chase's command veered off course. Flying amid deceptive visuals proved hazardous, as compasses faltered close to the Arctic and features below stayed veiled in unrelenting haze. Chase relied on estimated position when he caught a glimpse of the Shumagan Islands amid parting clouds. Pinpointing his location, he adjusted heading toward Dutch Harbor, opting to cross Akutan Island straight on to conserve time and gas. Plane captain and machinist's mate Albert Knack peered downward just in time. Amid a fleeting clearing in the vapor, he noticed an odd form in the wetland beneath, something alien to the Aleutian terrain. The vivid red insignias on the wings stood out clearly. Chase orbited the area repeatedly, marking the coordinates meticulously on his maps. The Zero looked surprisingly whole, an unimaginable windfall. He headed back to Dutch Harbor at once to alert authorities. Soon after, a salvage crew touched down close to the site. Their discovery surpassed even the boldest expectations. The Zero had come down in what might have been the sole area on Akutan where the peat was yielding enough to soften the landing, yet stable enough to keep the plane from submerging. The swamp functioned as a massive buffer, absorbing the energy that would have wrecked the structure on firmer soil. Beyond a shattered canopy, warped propeller ends, snapped undercarriage, and harmed wing edges, the fighter stayed essentially undamaged. The salvage group gently extracted Koga's remains from the seat and interred him with full rites on a slope facing the debris. They observed the heavy bandaging across his chest, hinting at prior wounds or safeguards for intense aerial stresses. His belongings, such as his sidearm and katana, were taken as valuable intel. Next came the grueling effort to haul a combat plane from an Aleutian quagmire. The retrieval spanned almost 3 weeks of exhausting toil in Earth's harshest environs. Laborers built an improvised path with timber and boards, gradually towing the seized plane over a half-mile of perilous terrain to a wide shore where a flatboat awaited. The process unfolded in constant wet chill, with tools icing or corroding by dawn, yet the reward justified every trial. By July's end, the Zero boarded a freighter bound for the continental U.S. The ship bearing this pivotal seized plane left the Aleutians in early August, navigating southward through seas recently battled over by Japanese and American navies. The captured Zero docked in Seattle on August 1, 1942, then shifted promptly to a scow for the trip to Naval Air Station North Island, adjacent to San Diego. It arrived in San Diego by mid-August, offloaded amid strict security, and relocated to a guarded facility. Round-the-clock sentries warded off any looters eyeing the precious find. News of the seizure buzzed through naval air communities with thrilling intensity. At last, since the Zero's shocking introduction at Pearl Harbor, U.S. technicians and flyers could scrutinize the fabled machine up close. Navy Captain William Leonard, future leader of a Pacific Carrier Task Force, described it as a boon revealing countless mysteries during a desperate era. Marine Lieutenant Colonel Kenneth Walsh, who endured the war as a top scorer with 21 victories, later credited insights from Koga's plane with teaching him how to evade a pursuing Zero, preserving his life on multiple occasions. Efforts raced to refurbish the Zero for flight without delay. Each idle day meant U.S. airmen confronted a foe shrouded in mystery. The repair squad toiled non-stop, logging every aspect of the build while fixing the mishap harms. Progress advanced at remarkable pace, fueled by pressing need and awareness that this lone plane could tip the scales in Pacific skies. The refurbishment yielded swift revelations about Japanese. The design approach for the Zero resembled that of a finely crafted timepiece, as one engineer observed, featuring smooth rivets across the fuselage and weaponry, integrated seamlessly into the wingskins to reduce aerodynamic resistance. Each part was engineered for optimal lightness and peak performance. The cockpit dashboard showcased impressive straightforwardness, free of unnecessary elements that could divert the aviator's focus, featuring only vital instruments positioned for quick glances. Access panels could be unlatched effortlessly by pressing designated areas with a fingertip, disengaging the inner mechanisms. The whole plane could be taken apart and put back together with just basic tools, offering a vital benefit for repairs in remote island outposts. Engineers found that the Zero's fully loaded weight ranged from 5,300 to 6,265 pounds, varying with ammo, fuel quantity, and setup, about 2,000 pounds less than the U.S. F6F Wildcat. This impressive reduction in mass stemmed from various choices. The fighter omitted pilot armor, depending on exceptional agility to evade strikes instead. Fuel reservoirs weren't self-sealing, prioritizing lower mass and greater volume over security. The structure employed the bare minimum of materials, providing sufficient robustness for expected stresses without extra buffers. Essentially, the Zero embodied a contrasting engineering mindset compared to U.S. pursuits. While American planes emphasized crew safeguarding and durable builds, enduring added heft for endurance, the Zero traded defensive features for speed and nimbleness. It was crafted as a dogfighter that triumphed via unmatched suppleness rather than withstanding hits. The seized plane uncovered further details. Its power plant, a 14-cylinder Nakajima Sakai radial engine delivering around 950 horsepower, incorporated a float-style carburetor that would play a key role in battles. The wings could fold manually for shipboard stowage, using a basic setup without hydraulics. Flight controls were skinned in fabric over metal skeletons to cut down on heft. Strikingly, the weapon setup was potent for such a featherweight machine. A pair of 7.7mm machine guns synchronized through the prop arc, plus two 20mm cannons housed in the wings. By September 20th, only 41 days after reaching San Diego, the Zero was flight-ready. The repair crew had swapped out the shattered canopy, realigned the tail fin and rudder, fixed the wing edges and slats, and fully reconstructed the undercarriage damaged in the impact. The stock 3-bladed Sumitomo prop was meticulously refinished and reinstalled. The plane received a fresh coat of paint, with the crimson Japanese Hinamaru emblems overlaid by U.S. blue discs and white stars. It resembled a Yankee bird clad in enemy garb. Lieutenant Commander Eddie Sanders, chosen as lead evaluator for the effort, had devoted the prior week to scrutinizing every facet of the Zero as technicians finalized the fixes. He logged hours in the seat getting comfortable with the Nipponese gauges, committing the controls to memory, and steeling himself for an aerial experience beyond his prior trials. An accomplished evaluator, Sanders was set to pilot a foe's machine whose handling traits were mere speculations drawn from spy data and battlefield accounts. Assuming the intel held true, the Zero outpaced, outclimbed, and outturned every U.S. counterpart. Should the intel falter, or if the wreck hid flaws, Sanders risked not returning from the debut hop. On the morning of September 20, 1942, Sanders entered the Zero's cockpit as its commander, not observer. The ground team fired up the motor, which ignited right away and purred steadily. The overhaul's success confirmed. Sanders rolled to the strip, aware of the crowd of specialists, spies, and high-ranking sailors observing from the control tower and tarmac. He pushed the power forward, and the Zero surged along the pavement with unexpected verve. The nimble craft rose after a brief takeoff run, ascending at a pace that would shine in any domestic design. Over the following hour, Sanders ran it through assorted trials, methodically probing its limits. He gained height, checked stall behavior, ran standard turns, and gauged the plane's responsiveness. His findings from that initial sortie would alter perceptions entirely. Right away, it became clear that the ailerons stiffened beyond 200 knots, slowing rolls at higher velocities and demanding heavy stick input. In his debrief, Sanders noted, "The Zero yawed left far more readily than right. The rapid aileron stiffness was striking and unforeseen. At slower paces, the Zero's agility matched the boasts of its Japanese handlers, able to carve inside any U.S. pursuer without effort. Yet past 200 knots, about 230 mph, the control surfaces on the ailerons grew progressively stiff and sluggish to handle. At higher velocities, the cloth-skinned wings inflated under aerodynamic pressure, demanding immense effort on the control stick to counteract. In contrast, U.S. aircraft featuring metal-skinned controls and hydraulic assistance retained complete maneuverability across their full speed range. During maneuvers involving deceleration, Sanders uncovered yet another major flaw. A sudden forward shove on the stick, generating negative G-forces, caused the Zero's power plant to sputter and cut out. Its float-based carburetor, optimized for level or positive G environments, failed to deliver fuel consistently under prolonged negative Gs. Once normal acceleration returned, the motor fired up again, yet the fighter glided helplessly for those critical moments. Sanders instantly grasped the strategic ramifications of this vulnerability. U.S. aviators, caught in a chase and unable to shake a trailing Zero, finally had a countermeasure. As he documented in his evaluation, initiate a vertical dive with negative Gs if feasible to widen the gap while the Zero's engine stalls from the stresses. Around 200 knots, execute a sharp right bank before the enemy pilot can align his guns. Over the following 25 days, Sanders logged 24 evaluation sorties, each exposing more insights into the Zero's strengths and shortcomings. He evaluated the plane across different heights, throttle positions, and battle setups. He simulated aerial duels with fellow evaluators, piloting F6F Wildcats and more modern types. The insights gathered proved invaluable. The Zero's top velocity fell just short of the F6F Wildcats, bucking frontline accounts that portrayed the Japanese machine as quicker. Sanders surmised this discrepancy might stem from added mass during rebuild, as the mechanics couldn't obtain precise substitutes for certain parts. Still, the Zero's staggering endurance, surpassing 1,900 statute miles, outstripped every U.S. carrier-based pursuer. It could stay aloft beyond 6 hours, allowing bomber protection far behind lines or wide-area sweeps overseas. The Zero outclimbed American rivals handily, hitting 20,000 feet quicker than an F6F could attain 15,000 feet. In tight, slow-speed turns, it finished a complete loop while U.S. planes managed only 3/4. Such traits clarified the Japanese edge in initial Pacific clashes. At reduced paces and in circling engagements, the Zero outperformed all U.S. deployments from late 1941 into early 1942. Yet Sanders's trials exposed how these edges hid fatal flaws. The fighter's slender build left it vulnerable to gunfire. Strikes that might hobble an American plane frequently doomed the Zero, absent protective plating or self-sealing tanks. Examination of seized Zero parts showed high-grade aluminum, but in gauges U.S. engineers deemed too thin. Constructed to bare essentials without buffers for hits, it tolerated no abuse. Sanders' comprehensive summary distilled the findings into practical guidance. U.S. flyers ought to steer clear of sluggish, twisting brawls where the Zero's agility ruled. Rather, they should launch plunging assaults leveraging the speed prowess of American designs. Facing a tailing Zero, dive sharply, ideally inducing negative Gs to silence its engine, then snap into a high-speed right roll beyond the foe's pursuit. American planes must rely on their robust shielding and heavy armament to weather impacts while unleashing lethal salvos against the delicate Zero. Group strategies should supplant solo scraps, with partners shielding flanks and staging joint strikes to blunt the Zero's agility. These directives circulated fleet-wide at record pace. Aviators gearing for battle got in-depth sessions on the Zero's traits and exploitation methods. The details fed into curricula, with trainers drilling the power dive and abrupt right maneuver on all rookies. Seasoned survivors of initial Zero skirmishes at last comprehended their adversary and the path to victory. The boost to spirits was immense. For 8 months, Navy flyers had confronted a seemingly unbeatable foe that could outmaneuver and outgain their mounts. Awe for the Zero had edged into dread. The standing U.S. protocol against surprise Zero attacks was mere flight, a stark concession of disadvantage. At last, American aviators possessed solid tactics for how to FIG pilots could now figure out how to engage the Zero effectively and come out on top. The aura of invincibility that had enveloped the Japanese aircraft started to fade. It remained a tough adversary, yet it was far from unbeatable. Flaws had been exposed, and U.S. aviators understood precisely what those vulnerabilities entailed and how to capitalize on them. However, the Akuten Zero's most significant impact extended beyond battlefield strategies. It shaped advancements in plane engineering, particularly for a warplane already in the works when Koga's machine went down in the Aleutians. The Grumman F6F Hellcat emerged as the tool that turned American insights into crushing victories in the skies. The tale of the Hellcat's origins and the role played by the recovered Zero in refining it would turn out to be just as vital as Sanders's evaluation runs. Historians have argued over the link between these two planes, with some insisting the Hellcat drew directly from the seized Zero, while others point out that the schedule precludes any straightforward effect. Reality falls in a middle ground: concurrent progress, well-timed intel, and Grumman's skill at weaving in fresh takeaways right up to the production phase. In January 1942, at Grumman Aircraft Engineering Corporation in Bethpage, Long Island, New York, Leroy Grumman pored over initial sketches for the upcoming F6F Hellcat, but the specs left him uneasy. The Navy demanded a successor to the F4F Wildcat, quicker and stronger, to tackle the dispatches from the Pacific, highlighting Japanese dominance in the air. Under the guidance of lead engineers Jake Swerble and Bill Schwendler, Grumman's crew had essentially scaled up and boosted the Wildcat. The blueprint seemed solid in theory, but Grumman feared it fell short. The opening weeks of 1942 delivered ever more worrying updates from the Pacific theater. U.S. flyers found themselves outmatched by Japanese Zeros in virtually every clash. Grumman's existing mainstay, the F4F Wildcat, held up as a sturdy, reliable craft, but couldn't hold its own. Battle dispatches showed the Zero surpassing the Wildcat in climb speed, maneuverability, and reach across almost all metrics. A major upgrade was essential, and it had to happen fast. Grumman's first take on the F6F, labeled F6F-1, revolved around the Wright R2600 Cyclone engine, delivering 100 horsepower. This promised greater thrust than the Wildcat's 100 horsepower Pratt & Whitney R1830, though Grumman doubted if the leap was sufficient. The firm had kicked off F6F-1 work in mid-1941, sealing the official agreement on June 30, 1941, almost a full year prior to Koga's Zero splashing down in the Aleutians. Progress accelerated into early 1942, fueled by pressing Navy mandates and Grumman's grasp that air power would decide the Pacific conflict. The Bureau of Aeronautics collaborated tightly with Grumman specialists, folding in observations from pilots back from Pacific duty. On April 20, 1942, 6 weeks ahead of the Battle of Midway and 7 weeks before Koga's last mission, Lieutenant Commander Edward Butch O'Hare stopped by Grumman's Bethpage plant. Fresh off patrols where he'd alone shielded the carrier Lexington from Japanese raiders, securing the Medal of Honor, O'Hare conferred with Grumman's staff about how the F4F Wildcat fared versus the Zero. His observations hit hard. The Zero exceeded speed projections from U.S. analysts, ascended beyond what its power plant should allow, and could slice inside the Wildcat's turns effortlessly. O'Hare pushed for U.S. planes with superior horsepower, sharper ascent capability, and enhanced forward views for the aviator. Just a day earlier, during his Medal of Honor ceremony, O'Hare had spoken with President Franklin Roosevelt, who inquired about requirements for the next carrier fighter. O'Hare's reply cut straight: a plane that will go upstairs faster. Bureau of Aeronautics. Lieutenant Commander A.M. Jackson, partnering closely with Grumman, ordered targeted modifications drawn from frontline lessons. Jackson insisted on raising the cockpit position within the body with a gentle downward tilt from the front fuselage to the engine housing, ensuring top-notch sightlines over the nose. He told Grumman experts plainly, "You cannot hit them if you cannot see them." Such adjustments made their way into the F6F blueprint well before anyone laid eyes on Koga's Zero. Then, on April 26, 1942, 5 weeks prior to Koga's doomed sortie, the Bureau of Aeronautics issued a pivotal call that would stamp the F6F's essence. Drawing from Pacific skirmish tales and O'Hare's counsel, Boulanger instructed Grumman to fit a beefier power plant into the second F6F mock-up. They ditched the Wright R2600 for the Pratt & Whitney R2800 Double Wasp, an 18-cylinder radial churning out 2,000 horsepower. This matched the power source in the Vought F4U Corsair and Republic P-47 Thunderbolt. The introduction of the R2800 Double Wasp engine, often likened to the Thunderbolt, marked a 50% boost in power compared to the initial F6F1 configuration. To accommodate this upgrade, Grumman reinforced and revamped the F6F structure, adapting the engine mounts, airflow mechanisms, and key structural elements across the plane. These alterations pushed back the timeline somewhat, yet the enhanced capabilities promised to pay off handsomely. Grumman forecasted that the upgraded engine would deliver a 25% improvement in overall performance relative to the baseline model. Several influences aligned to prompt this engine switch. The R2800 had demonstrated solid dependability during trials and was ramping up for use in various other planes. Unlike the troubled Wright R2600 Cyclone, Pratt & Whitney could supply the R2800 units promptly. Above all, frontline feedback underscored that modest tweaks wouldn't cut it anymore. U.S. fighters demanded a dramatic surge in capabilities to rival or outpace the Zero. The initial XF6F1, powered by the Wright R2600 Cyclone, took to the skies for the first time on June 26, 1942, piloted by Bob Hall during testing. That flight occurred just 8 days prior to Koga's crash in the Aleutians and 6 weeks ahead of the Zero's recovery. The aircraft handled smoothly, showing no major flaws, but its 1,700 horsepower output with the Cyclone only reinforced Grumman's view that greater thrust was essential. The follow-up prototype, the XF6F3, equipped with the 2,000 horsepower R2800 Double Wasp, lifted off on July 30, 1942. This came 20 days following the Akutan Zero's discovery, though 2 months before it could be rebuilt and evaluated in flight. The XF6F3 surpassed projections, with the extra horsepower revolutionizing the aircraft's ascent rate and velocity, positioning it to challenge the Zero head-on. However, Grumman's work on the Hellcat pressed onward. Over the course of summer 1942, the team fine-tuned the blueprint using fresh insights from Pacific theater engagements and reconnaissance. Once the Akutan Zero reached San Diego in mid-August, in-depth specs quickly reached the Bureau of Aeronautics and Grumman. Though the prize hadn't flown yet, hands-on inspections uncovered vital details on its build, mass, weaponry, and layout. From a strategic standpoint, this intel hit at a pivotal phase for the F6F program. The core framework was locked in, the power plant chosen, and early test models airborne, but manufacturing hadn't kicked off, allowing for straightforward integrations. Grumman specialists pored over the Zero's particulars eagerly, seeking optimizations to not only equal, but outperform the enemy fighter. Loaded out, the Zero tipped the scales at 5,300 to 600 pounds, while the F6F would exceed 12,000. This substantial heft disadvantage, over twice as heavy, necessitated offsetting through superior propulsion and clever engineering. Grumman's ethos stood in stark contrast to Japan's tactics. Instead of trading safety for agility like the Zero, the F6F aimed to blend both effectively. After reviewing the Zero intelligence, founder Roy Grumman resolved that his firm could rival or top the Japanese plane in key areas without skimping on pilot shielding, puncture-resistant fuel cells, or sturdy airframe integrity. The F6F would counterbalance the added mass via the R2800's potent output. That choice defined the project's trajectory. Constructed for resilience, the F6F could endure impacts that would cripple a Zero. It safeguarded its aviator with seatback plating and shatterproof canopy glass. Self-sealing tanks prevented explosive blazes from strikes. Backup redundancies and a fortified skeleton handled rough deck touchdowns and fight-worn stress. The mass drawback got neutralized by sheer muscle and smart features that maximized every bit of potential. Insights from the Akutan Zero, paired with battle dispatches and test runs by Sanders in September and October, guided targeted refinements as the F6F geared up for assembly. Optimized for swift operations, the F6F's wings featured a distinct airfoil profile and surface controls diverging from the Wildcat's setup. Hydraulically assisted and sheet metal-clad ailerons guaranteed responsive handling across the speed spectrum. This fix targeted the elevated speed control jams Sanders noted in the seized Zero. Thus, the F6F could maneuver sharply where the Zero's surfaces stiffened. Opting for a pressure-fed carburetor over the Zero's float-style setup, the F6F's fuel delivery sustained operation amid inverted forces, closing the vulnerability Sanders had demonstrated in evaluations. A Hellcat flyer could thus plunge from a trailing Zero without the motor stalling in that vital instant. The F6F's framework was engineered to withstand 9G in positive forces and 6G in negative ones, surpassing the Zero's structural thresholds by a wide margin. As a result, pilots flying the F6F could execute bold turns without worrying about the airframe disintegrating, whereas Zeros pursuing them faced the danger of coming apart mid-maneuver. The weaponry was upgraded to 650 caliber machine guns, an improvement over the Wildcat's 4. Subsequent models included choices like a pair of 20mm cannons alongside 450 caliber guns. This focused barrage could shred the fragile Zero in mere seconds of fire, and the F6F's reinforced build allowed it to shrug off incoming shots. Cockpit visibility stood out, thanks to the elevated seating that offered unobstructed sightlines everywhere. This directly tackled Jackson's point that unseen targets couldn't be engaged. Drawing from insights on the thatch weave and similar protective strategies, the designers highlighted how clear views enabled better teamwork among squadron mates. On October 3, 1942, the initial F6F3 production model took to the skies, merely 2 weeks following Sanders' preliminary evaluations in the Akutan Zero. Such precise scheduling was intentional. Manufacturing had been held back on purpose until the team integrated the freshest intel available. Claims that the F6F stemmed directly from the Akutan Zero don't hold up, since its core layout existed prior to Koga's incident and the power plant switch was decided well before the Zero's recovery. Still, that schedule let Grumman fine-tune the Hellcat's ultimate setup using details from the seized plane, weaving in combat strategies right before full-scale output began. The earliest F6F3 units started arriving at carrier groups in the opening months of 1943. Fighting Squadron 9 got the inaugural combat-ready Hellcats in February 1943, boarding the carrier Essex for drills and preparation. Aviators responded with real excitement to the fresh plane. Having battled for months in F4F Wildcats against more advanced Japanese foes, they saw the F6F as a massive upgrade in performance. It outpaced rivals, ascended more sharply, packed greater punch, provided superior outlook, and handled with a sturdiness the Wildcat lacked. Flyers soon realized the F6F was incredibly straightforward to handle. Grumman crafted it intentionally for novices straight out of flight school, anticipating the surge of green pilots due to wartime growth. The plane avoided nasty quirks or lethal surprises that might doom a careless operator. It stayed steady, reliable, and lenient with errors. Touching down on carriers, the toughest part of shipboard flying, proved simple in the Hellcat. Its sturdy undercarriage soaked up rough touchdowns that would crumple weaker designs. The wide field of view helped aviators gauge landings accurately. The flight controls stayed lively even at the sluggish velocities needed for deck approaches. Output surged at an incredible rate. Grumman erected a dedicated plant in Bethpage for the F6F, with the first units emerging before the facilities were fully finished. During the 1944 high point, the company churned out 644 planes in 1 month alone, one every hour, a benchmark in plane manufacturing that's unmatched. The operation's magnitude was immense. Every F6F demanded around 20,000 components, gathered from countless suppliers. The Pratt & Whitney power plants came from 3 distinct plants, then ferried to Bethpage for fitting. Grumman orchestrated this vast effort with such exactness that it left experts in awe. A lot of the praise belonged to Jake Swerble, the firm's manufacturing mastermind, who streamlined operations and logistics like never before. Plenty of Grumman staff were aircraft-building rookies, but they delivered the war's top carrier-based interceptor. From that debut production hop in October 1942 through the war's close in November 1945, a roughly 37-month stretch, Grumman delivered 12,275 F6F Hellcats from one integrated site. The F6F entered battle on August 31, 1943, some 15 months post-Akutin Zero recovery and 11 months after Sanders' debut run. Planes from Fighting Squadrons 5 and 9, launching from carriers Yorktown and Independence, struck Marcus Island during a carrier strike. The operation triumphed decisively. Japanese interceptors failed to launch, with multiple ones wrecked while parked. 2 Hellcats fell to ground defenses, yet in dogfights, the F6F showed instant dominance. In the ensuing period, the Hellcat turned into the go-to escort for U.S. carrier task forces, slowly ousting the F4F Wildcat from big decks, while the older type lingered on light carriers. By the start of 1944, it armed 15 carrier wings and was swiftly claiming primacy as the Pacific's leading U.S. Navy fighter. Insights from the Akutin Zero shaped every facet of F6F tactics was shaped by this reality. Aircrews received instruction to steer clear of low-velocity turning duels, except when they held a clear edge in height or numerical superiority. Rather, the F6F approach focused on rapid slashing maneuvers, plunging from elevation to gain velocity, executing one quick shooting run, and then climbing back upward before the nimbler Zeros could react. The Thatch Weave, devised by Lieutenant Commander John Thatch prior to the capture of a Zero, emerged as the core defensive strategy across all F6F units. Upon surprise attacks from Zeros, F6C flyers operated in paired formations offering mutual coverage, zigzagging alternately to ensure that any Zero chasing one machine would swiftly encounter frontal gunfire from its partner. This method countered the Zero's agility edge by compelling the enemy flyer to abort the pursuit or risk a frontal clash in which the F6F's greater armament and armor prevailed decisively. Crews learned to leverage their machine's velocity and thrust to control the fight's conditions. Should the circumstances suit the F6F, they would press the action. Otherwise, they exploited their superior pace to withdraw, reposition, and strike from a position of strength. The F6F's ascent performance enabled rapid recovery of height following descent strikes. Its quickness permitted evasion of dire scenarios. Its range supported extended patrols and deeper pursuits of retreating foes beyond the Zero's reach. On November 23, 1943, in the Gilbert Islands, F6F Hellcats from the carrier Essex clashed with Japanese Zero interceptors above Tarawa, marking the initial large-scale evaluation of the innovative fighter versus Japan's premier design. 30 Zeros climbed to challenge the U.S. assault, sparking a fierce aerial melee over the assault shores. As the chaos subsided, U.S. aviators reported downing 30 enemy planes while sacrificing just one F6F. The Tarawa fight exemplified the full potential of the F6F's engineering. U.S. flyers, often novices, confronted battle-hardened Japanese experts in Zeros and overwhelmed them completely. The blend of advanced plane capabilities, proven strategies drawn from Zero vulnerabilities, and rigorous preparation forged an invincible approach. The engagement's results reverberated through leadership on both sides. For the U.S., it confirmed the F6F's blueprint and the combat principles derived from the Akutin Zero analysis. For Japan, it exposed how American planes had not only matched but exceeded the Zero's strengths. The era of unchallenged Japanese dominance in the air was drawing to a close. Yet, Tarawa served merely as an opener. Over the subsequent 20 months, the F6F validated its prowess in every key Pacific clash, amassing the most commanding war record among all U.S. fighters in World War II. June 19, 1944, in the Philippine Sea, west of the Mariana Islands. F6F Hellcats from 15 U.S. carriers, 7 heavy fleet carriers, and 8 light ones within Task Force 58 braced for confrontation with the biggest Japanese carrier-based air arm since Midway 2 years prior. Japan deployed 9 carriers and unleashed successive formations against the American Armada targeting Saipan. The ensuing action earned the moniker of the Great Marianas Turkey Shoot, history's most lopsided air-sea battle. The initial Japanese assault of 69 planes saw 42 fall short of the U.S. formation. Of the 27 that broke through to the carriers, none succeeded amid a barrage of defensive fire and relentless F6F pursuits. The follow-up group of 107 lost 97 without launching any strikes. Japan's carrier-based forces faced total dismantling. Across the day, Japanese decks dispatched 370 planes in repeated waves. Just 130 made it back. F6F Hellcats, patrolling defensively over the U.S. task force and stalking enemy raids, accounted for nearly all the kills. U.S. casualties ranged from 23 to 30 aircraft, with most crewmen recovered from the waves. The blow to Japan proved devastating on multiple levels. The carrier squadrons, laboriously reformed after Midway's toll, were eradicated. Seasoned instructors who had mentored the latest recruits perished. The planes reserved for this pivotal showdown vanished. Japan's sea-based air power could not rebound from that day's devastation. The Philippine C-class showcased the F6F at its zenith. The plane's outstanding stamina facilitated non-stop defensive sweeps around the fleet. Its ascent speed guaranteed interceptions of approaching raids at ideal heights. Its velocity supported chases of withdrawing Japanese formations. Its armament and durability ensured dominance in direct confrontations. Above all, though, the F6F's straightforward controls empowered even less seasoned U.S. pilots to handle it capably in battle. By the summer of 1944, America outpaced Japan in generating aviators, and the F6F enabled these fresh recruits to enter. American aviators entered battles assured of their ability to endure and prevail. In contrast, Japanese airmen underwent progressively shorter preparation periods amid escalating fuel scarcities and the depletion of experienced trainers. By the closing months of 1944, these pilots were thrust into fights with roughly one-third the flying time that their U.S. counterparts accumulated. This gap in expertise, coupled with the F6F's engineering advantages, triggered a catastrophic decline for Japan's air forces. Each clash drained Tokyo of invaluable crew members, whereas U.S. casualties were swiftly offset by a robust system churning out thousands of fresh flyers every year. The F6F's role in securing U.S. triumph went further than dogfights in the sky. Engineers modified the plane into various tailored versions to meet distinct operational demands. Models like the F6F-3N and F6F-5N incorporated radar units housed in a bulge on the right wing, enabling them to counter Japanese nocturnal bombing assaults. Although the added gear trimmed maximum velocity a bit, pilots in the night defense role deemed the advantage more than sufficient. These F6F night interceptors notched impressive feats against Japanese evening intruders, downing planes that once struck freely under the veil of night. The F6F-3P and F6F-5P photo recon types swapped armaments for imaging devices, performing vital scouting runs over hostile zones. Their pace and endurance let them venture far into occupied territories, snap pictures of objectives, and withdraw ahead of pursuing foes. Subsequent F6F-5 models were upgraded to haul 2,000-pound bombs via a central mount and rocket launchers beneath the wings, converting the pursuit plane into a potent strike platform. F6Fs loaded with ordnance and projectiles delivered crushing ground assistance to Marine and Army units battling on Pacific atolls, targeting enemy fortifications, gun emplacements, and soldier groupings with accuracy surpassing that of shore-based guns. As World War II drew to a close, the F6F Hellcat's tally stood unparalleled among U.S. fighters. It was officially recognized for 5,163 hostile planes downed in Pacific sky duels by Navy and Marine aviators, plus 60 more in distant regions, totaling 5,223 when factoring in British Royal Navy Fleet Air Arm successes. Just 270 F6Fs fell to enemy fighters, yielding a staggering 19.1 destruction-to-loss rate. Versus Japanese Zeros in particular, the figure hit 13.1. Such figures underscored the fusion of the plane's exceptional qualities, proven strategies drawn from Zero evaluations, and a rising caliber of American airmen confronting a weakening foe from Japan. No other Axis plane spawned as many aces on the Allied side during the conflict. From 305 to 307, Navy Hellcat drivers earned ace credentials with at least 5 kills. with minor discrepancies based on how joint victories were tallied. The service's leading scorer, Commander David McClelland, claimed all 34 of his triumphs in F6Fs. The Hellcat's battlefield supremacy grew so overwhelming that wartime Japanese flyers suffered what U.S. spies termed zero fatigue, an admission that tangling with F6Fs often meant doom. Enemy pilots shied away from scraps when they could, opting to plunge downward or vanish into cloud cover instead of clashing. This mental edge proved as vital as the machine's edge, permitting U.S. carrier task forces to maneuver almost unhindered, confident that aerial resistance from Japan would be sparse and futile. The shift from initial wartime encounters was profound. Back in 1942, U.S. flyers had evaded Zeros at every chance. Come 1945, it was Japanese aviators dodging Hellcats. The reversal had fully materialized. Pinning down the Akuten Zero's exact contribution to this shift defies easy measurement, yet its value is beyond question. The seized machine offered the initial in-depth insights into the Zero's strengths and flaws. Sanders' evaluation flights exposed exploitable vulnerabilities for battlefield use. The gathered specs shaped key choices in the F6F's development at a pivotal stage when adjustments remained feasible. Above all, the Akuten Zero shattered the aura of invulnerability around the Japanese machine, demonstrating it as a craft with defined assets and clear shortcomings. Together, the F6F Hellcat and the operational wisdom from the Akuten Zero forged a powerful alliance that revolutionized U.S. carrier-based air power. The F6F wasn't built solely due to the Akuten Zero, but its features were honed using data from the prize. The methods U.S. pilots employed weren't invented through Zero study alone, but they were confirmed and refined via Sanders trials and follow-up reviews. What emerged was a cohesive framework of planes, maneuvers, preparation, and manufacturing might that crushed Japanese air efforts. At the conflict's conclusion, Japan had manufactured about 10,500 Zeros. The Grumman F6F Hellcat served as the main American fighter during the war, with the United States manufacturing 12,175 of them over 37 months, alongside thousands of F4U Corsairs and additional aircraft types. This vast output highlighted U.S. manufacturing prowess, yet the edge in battles stemmed from the F6F's engineering advantages and the smart strategies that maximized its strengths. The Akuten Zero met its end in February 1945, unexpectedly during a training mishap instead of in action. While preparing to take off at Naval Air Station North Island, an SB-2C Helldiver bomber veered out of control and collided with the stationary Zero, its blades shredding the enemy plane apart. William Leonard recovered various instruments from the debris and contributed them to the National Museum of the United States Navy. Fragments were also kept at the Alaska Heritage Museum and the Smithsonian National Air and Space Museum. Though the plane itself vanished, its influence endured through each F6F engaged in fights, every U.S. aviator aware of the Zero's vulnerabilities, and all strategy guides that drew from Sanders' evaluation flights. Koga's remains, first interred on Akuten Island, were disinterred by U.S. Graves registration units in 1947 and relocated to Adak Island, farther along the Aleutian chain. By 1953, the Adak burial ground had been dug up, and 236 sets of remains, probably including Koga's, were sent back to Japan for proper rites. The 19-year-old flyer, who perished so young, unknowingly aided in his nation's downfall. His impeccably intact machine exposed critical details that sealed the fate of countless fellow Japanese. Scholars still debate the Akuten Zero's role in history. Certain experts claim it ranked as the Pacific Theater's top intelligence haul, surpassing code decryption or any other breakthrough. Critics, however, maintain that U.S. success was assured anyway, with the Zero's seizure simply speeding up existing shifts. Japanese scholar and Air Self-Defense Force Lieutenant General Masatake Okumiya, who served as a staffer in key Pacific carrier clashes, remarked that obtaining the Akuten Zero hit Japan as hard as the loss at Midway. Exposing the Zero's mysteries to U.S. technicians and flyers marked a devastating leak in security, with effects echoing across the war's final phases. Fighter veteran William Leonard dubbed the seized Zero an invaluable gem that revealed vital insights right when they were desperately needed. Marine top scorer Kenneth Walsh attributed his survival in multiple scraps to intel from Koga's aircraft. That strategic insight helped him endure initial clashes that could have proven deadly otherwise. Reality probably blends these views. The Akutan Zero didn't single-handedly secure U.S. triumph, which depended on factory output, code cracking, sub-operations, and many more elements, but it formed a vital link in the chain, showing up precisely when it could shape plane innovations and combat approaches. Absent the Akutan Zero, the F6F would have remained a top-tier machine. U.S. factories would have outpaced Japan's anyway, and victory for America would probably have come still. Yet the path might have dragged on, claimed extra U.S. casualties, and carried more doubt on countering the Zero's prowess. The staggering 19-1 kill rate emerged from a flawless blend of influences: aircraft engineering that balanced speed with crew safety, combat methods informed by probing foe strengths and flaws, pilot preparation tuned to battlefield truths, manufacturing scale granting force advantages, and vitally in-depth data on the adversary's key asset, pulled from one almost complete specimen snagged by luck in the Aleutian wilds. Post-World War II, U.S. Airmen who piloted F6F Hellcats came together at reunions spanning years. Numerous Hellcat flyers who once ruled Pacific airspace now recounted tales and paid tribute to lost friends. At these events, presenters often highlighted the Akutan Zero and its yielded knowledge. They discussed how grasping the Zero's limits boosted their battlefield assurance. They recounted applying the rapid descent and sharp right-turn maneuver that Sanders uncovered. They detailed how the F6F's build reflected takeaways from the retrieved Japanese craft. Survivors repeatedly stressed one core idea. "We heard the Zero was unbeatable," shared one ex-fighter expert. "We bought that tale after witnessing its damage to our planes in initial fights. Then, Alaska's captured bird taught us its flaws. We found out it struggled to maneuver quickly at top speeds. We discovered its power plant stalled during sudden dives. We learned it is vulnerable and prone to igniting upon impact. Overnight, its aura of untouchability vanished. It became merely one more plane, something our pilots could outmaneuver with clever flying. The F6F provided the essential equipment. The Akutan Zero delivered the crucial insights. United, they secured our triumph." The F6F Hellcat stayed active on the front lines until the conclusion of World War II, slowly giving way to the F4U Corsair once issues with carrier landings for that plane were sorted out. Post-war, Hellcats were swiftly removed from active naval fleets, supplanted by jet aircraft and newer prop-driven fighters. Numerous examples ended up in reserve units, where they operated well into the early 1950s. Some underwent modifications into drone targets or were dismantled. The final Navy Hellcat left service in 1954, merely 9 years following the war's close. This swift outdatedness highlighted the blistering pace of progress in aviation tech during and beyond World War II. A machine cutting edge in 1943 had become utterly obsolete by 1954, no match for jets that soared at double the speed and ascended at triple the rate. Yet the Hellcat's battlefield achievements guaranteed its enduring legacy. Preserved F6F models grace exhibits in museums throughout the United States, with many meticulously refurbished to take to the skies again. Spectators at airshows gaze in wonder as these classic Hellcats execute maneuvers. Their signature roar and silhouette summon memories of a time when U.S. carrier-based air power rose to supremacy via superior design and strategic acumen. Around 70 F6F Hellcats endure today in museums and personal holdings around the globe. 7 are still flight-capable, all located in the United States, and they routinely appear at air shows and memorial gatherings. Every such outing serves as a tribute to the 12,000 units produced on Grumman's production lines, the 34,000 aviators who piloted them in battle, and the 5,000 adversary planes they eliminated. The Akutan Zero persists solely in scattered remnants, displayed in museums and in vast troves of evaluation documents and intel summaries stored at the National Archives. Nevertheless, its influence on the Pacific theater vastly surpassed its tangible form. One plane seized by luck, evaluated over several months, and lost in a mishap played a role in U.S. success that defies exact quantification, yet remains undeniable. Lieutenant Commander Eddie Sanders, the evaluator whose inaugural flight, the Akutan 0, survived to observe the F6F's wartime feats. He persisted in diverse testing and assessment positions in aviation for the duration of the conflict, aiding initiatives for various plane designs. Following the war, he left the Navy and joined the aerospace sector. His proficiency in plane evaluations proved invaluable amid the post-war surge in tech innovation. He died in the 1970s, having seen naval air forces evolve entirely from piston-engine combatants to faster-than-sound jets. Sanders seldom discussed his involvement with the Akutan 0 in public forums, viewing it as just another duty in a lifetime committed to carrier aviation. Still, colleagues who worked alongside him appreciated the significance of his efforts. His meticulous evaluations, thorough documentation, and perceptive observations directly shaped U.S. combat strategies and, more subtly, influenced choices in F6F engineering. He embodied the unassuming expert who excelled precisely when his contributions counted the most. The overarching takeaway from the Akutan 0 and F6F Hellcat narrative reaches far past World War II. Contemporary armed services invest fortunes in espionage, expert evaluations, and risk evaluations precisely because the Akutan 0 demonstrated the immense worth of in-depth comprehension of foe strengths. Each seized enemy plane, each informant sharing specs, each intel channel exposing vulnerabilities represents a potential Akutan 0, a vital element that can open doors to strategic and innovative edges. Grasping an adversary's strengths and flaws often determines triumph or loss. One analyzed artifact, if leveraged correctly, can sway weapon creation, tactic formulation, and fight resolutions. The Akutan 0 emerged right when it could shape F6F progress. Sanders's evaluations uncovered flaws just as aviators required reassurance against the 0. The strategic takeaways spread when instruction could integrate them. A year prior or subsequent, the effect could have been slight. The timing proved ideal, and the U.S. capitalized on it completely. In 1942, the 0 stood as perhaps the premier carrier-based fighter globally, outclassing much of America's lineup in key areas. However, the U.S. capacity to manufacture thousands of F6Fs, prepare tens of thousands of flyers, and maintain operations over vast seas provided edges that the 0's superior specs couldn't surmount. Excellence counts, yet mass production carries its own potency, particularly when paired with sharp intel and robust strategies. The F6F Hellcat and the Akutan 0. These elements form the dual facets of this pivotal equation. The F6F Hellcat arose from U.S. manufacturing prowess, technical ingenuity, and the fusion of battlefield insights. Meanwhile, the Akutan 0 stood as luck's boon to Allied espionage, a serendipitous discovery that unveiled essential details about Japanese strengths. United, they forged an invincible alliance, elevating American carrier operations from early 1942's defensive struggles to mid-1944's unchallenged superiority. The inexperienced Japanese aviator who perished in an Aleutian swamp had no idea his intact plane would hasten his country's downfall. His comrades, assuming he'd endured, couldn't foresee that their restraint in sparing the wreck would seal the fate of countless fellow fighters. The U.S. recovery teams toiling in that remote Alaskan wetland were unaware they were retrieving the secret to mastering Pacific airspace. Likewise, Eddie Sanders, as he guided that seized 0 on its debut U.S. run, likely didn't grasp how his evaluations would shape a plane destined to clinch the conflict. Yet history unfolds through such instances where serendipity meets readiness, where luck rewards the prepared, and where one intelligence nugget arrives precisely when needed to sway outcomes well beyond its surface value. The Akutan 0 marked such an instant, and the F6F Hellcat became its enduring impact. A single seized plane, a proficient evaluator. One instant when reconnaissance, innovation, and combat strategy merged to yield a system boasting a 19.1 victory rate, purging Japanese forces from Pacific heavens. The evolution of U.S. naval air forces from initial underdogs to supreme powers stemmed from blending production scale, design brilliance, adept aviators, and reconnaissance assets. The Akutan Zero exposed vulnerabilities in the ostensibly unbeatable enemy interceptor. The F6F Hellcat was crafted and deployed to capitalize on those flaws without mercy. As U.S. flyers engaged in F6F Hellcats, they wielded not merely advanced hardware, but informed tactics. They understood the Zero's flaws thanks to Eddie Sanders' revelations. They mastered exploitation through revised combat guidelines drawn from his trials. They embraced triumph because the aura of Japanese supremacy had crumbled under concrete evidence from the retrieved machine. That 19-1 success rate emerged as the logical outcome, evidence of what preparation can forge when opportunity knocks and expertise converts it to decisive edge. The tale of how one evaluator's work with a captured Zero molded the F6F Hellcat into a 19-1 destroyer underscores that conflicts hinge not solely on bravery and armament, but on reconnaissance, flexibility, and gleaning lessons from adversaries. The F6F Hellcat and Akutan Zero jointly inscribed a lasting segment in flight chronicles, echoing strongly 8 decades on. It shows that the most profound triumphs often arise not from mere devastation, but from profound comprehension.